Are you? Am I audible? Am I audible? Okay. The whiteboard is seen. Whiteboard is seen. Okay. Whiteboard is not seen. Okay. All right. Let me share the whiteboard. Okay. Abhishek, can I ask a question? Okay. Abhishek, what are the elements of the given system? Okay, I hope now it is seen. Now it is seen whiteboard. Gargi, Shubham. Seen now. Are you able to see the whiteboard now? Yes, Anish. Okay, wait. Now wait. I hope now it would be visible. Hopefully. Okay, thank you. It has been sorted out. Thank you. So I would be solving one or two numericals on entropy change. That is idea today. Okay. So the plan is to solve one or two numericals. On entropy. Okay. Before that, let me give you instructions about the open book test. Instructions about TD open book test. Okay, I'm just giving you the instruction before I start the test. One is we will be having 6 numericals, 5 marks each approximately. This is a tentative. And the numericals would be given in the form of MCQ test. They would be framed as MCQ test. framed as MCQ test, uh, which you need to submit, okay, online. And also, okay, sorry, uh, uh, 5 numericals, 6 marks, okay, 6 marks, and 30 and the numericals will be framed as MCQ test, which you need to submit online, so that your results would be out immediately, okay. Results would be declared immediately. But more important than this is, you need to actually solve this numericals step by step, solve them step by step in notebooks, okay, step by step in notebooks, okay, and submit it, and submit photos, that is upload it, I mean to say, upload the photo on the, upload it on Google Classroom, okay, on Google Classroom, just as you had uploaded your assignments, just as you had uploaded your assignments. So when we would be getting both your MCQ results and your actual solved thing, step by step solved thing, then and then we would be considering that your open book test is over, okay. I hope this is very clear to you, right? I don't feel that that needs an repetition, okay. 5 numericals would be asked for 6 marks. This is basically application of the numericals would be on application of the first law of thermodynamics, okay, closed system, open system, steady flow system, and whatever has been covered, all those concepts which have been covered in the videos, that those would be used, okay, for framing those numericals, right? So you need to view those videos clearly, okay. The videos on steady flow energy equation, the videos on first law of thermodynamics and second law of thermodynamics, okay. You have sufficient time, okay, and based on the concepts, the numericals are framed, okay. I hope that this instruction is enough. This on the entropy. Let me rub this, and you need to take down the name of entropy now. Won't be asking you numerical entropy, okay, for this test. For this test. Okay. Then structural numericals in terms of structural. Okay. One 1 kg of water, okay, 1 kg of water, which is at let us say, just a minute, let me frame that question. Which is at 0 degree centigrade, let's just say, which is at 0 degree centigrade, 0 degree centigrade, is brought in contact with, is brought in contact with the surroundings, the surrounding, which is the source, surrounding, the surrounding is a source, at surrounding the source at 100 degree centigrade, 100 degree centigrade, okay. So you need to and entropy. Say yes. If your question is clear, you simply say yes. Yeah, Saurabh, I understand that the voice is breaking, but I have already written down the question on the whiteboard. So you can copy down the question and start solving it. Use write down this question and start solving it. Now let me ask you, what would happen to the entropy of water, whether it will increase or decrease? I want you to answer this question first before solving this. What would happen to the entropy of water, whether the entropy of water would increase or the entropy of water would decrease? Whether the entropy of water would increase or the entropy of water would decrease. Please answer this. Okay, Siddhil is saying, yeah, Siddhil. Whether the entropy of water would increase or decrease. Siddhil is right. Pranav is right. Samir is also right. Siddhil, Pranav, Lucky Singh is also right. Okay, all Tejas, Gargi, Ganesh, all are right. So the entropy of water would increase. Okay, what would happen to the entropy of the source? What would happen to the entropy of the source? Whether it will increase or decrease? What will happen to the, Kunal, you are right. What would happen to the entropy of the source, the reservoir, which is at 100 degrees centigrade? Whether it will increase or decrease? What would happen to the entropy of the reservoir? Whether it will increase or decrease or it will remain constant? Sridhar is saying that entropy would be infinite. Okay. Samir is saying it would decrease. Pranav is saying it will remain same. Vedant is saying it will remain constant. Ganesh is saying it will remain constant. Kunal is saying it would decrease. The answer is no, Sushant, it is wrong. Adarsha is saying decrease. So the answer is the entropy of source would decrease because heat is lost by the source. Heat is lost by the source. So let us now, Rutraj, right? So let me now discuss this. You first find now the entropy change of water using the basic expression. You find the entropy change of water using the basic expression. Okay. So if you are able to find that, you please calculate and tell me the answer. I am rubbing this question. Okay, and I hope you have copied it down, and I would be just now solving this. Okay, let me erase this completely, and I'll just draw schematic for this problem now to show you what is happening. Okay, so there is water. Let us say the water is a system. The water is a system. Okay, and this is a system means what is happening is this water is at 0 degree centigrade initially, and this water gets heated up to 100 degree centigrade. The water is initially at 0 degree centigrade, and the water gets heated up to 100 degree centigrade. Now, how is the water getting heated? The water is getting heated because of the heat transfer. Because of the heat transfer. Okay, the heat is being transferred. Now, where from is the heat coming? Where from is the heat coming? The heat is coming from a reservoir. Okay, the heat is coming from a reservoir source in this case, because it is giving the heat, so that reservoir is a source, and this reservoir is at a temperature of 100 degree centigrade. 100 degree centigrade. Okay, and what you are asked to find out is what is the entropy change of water, that is asked as the first part of the question. Okay, so how do you find the entropy change? The entropy change is found as the integral of del q by t from which degree centigrade to which degree centigrade? From 0 degree centigrade to 100 degree centigrade. 100 degree centigrade. Okay, and mind well that we are not supposed to use degree centigrade, but you need to convert it into Kelvin. Convert it into Kelvin. So it means that entropy change of water, you need to integrate del q by t from 273 to 373. 373. Okay. So how will you integrate this? How will you solve this now? Anybody has figured it out? Anybody has figured it out? Okay, so let me write down. So you know that this water gets heated, and this heating would depend upon the specific heat of water. The how fast and how much heat is required, not fast, but how much heat is required for heating would depend on the specific heat of water. And you studied in physics that specific heat of water is 4.187. 4.187. Okay, so this del q, you know that elemental del q would always be mcp dt. Elemental del q would be mcp dt. So what we need to do is that for water, because we are talking about water here, we need to substitute this del q, which is a mass of water. Okay, mass of water, a specific heat of water into dt upon t from 273 upon t from 273 to 373. So we need to integrate this now. Okay, so integrating this, you understand how to integrate this. Now mass of water is constant, that is mw, and it is given as 1 kgs. Cp of water, you know, it is also constant, so this is again Cp. Integral of dt by t from 273 to 373. Okay, so this, if you solve, this integral would be m cpw ln, right, t2 by t1, t2 by t1. Okay, solve this and tell me the answer. Solve this and tell me the answer. Okay, solve this and tell me the answer.
the main objectives of material handling system?
Kunal, Kunal is having a different answer. It's log to the base e. Okay, log to the base e.
Only two. There are many, the number of objectives.
Most of you are getting incorrect. I don't know why they have what mistake they have done. This is okay. Alien E250 is 0.312. Mass of water is 12.